Good morning. Today we are going to be dealing with reasonings in algebra and geometry. And the main objective is the student will be able to connect reasoning in algebra and geometry. The properties of equality are to the student toolbox for writing proofs using deductive reasoning. It is important to make a connection between algebraic proofs that student unknowingly completed throughout all of algebra and the proofs that students will complete in geometry. Students should have a clear understanding that the process of solving an equation and as is an algebraic proof, although the justification for each steps are not generally written down and are often not even discussed. Students should realize from this lesson that proofs are not unique to geometry. So the first one, reflexive property of equality, state that any quantity is equal to itself. Example, A is equals to A. And a clear example is given. So you have a diagram where line BD is equal to the other line like BD. Symmetric property of equality. If one equality quantity equals another, then the second is equal to the first. So if A is equals to B, then B is also equals to A. It's just the idea of two halves. So one is equal to the other. It comes from the word symmetry. So symmetry property of equality. Transitive property. For transitive property, we're talking about if A is equals to B, then B is equals to C. So therefore, A is also equal to C. So it's sort of like a transition where we are saying if one item is equal to another item, and the second item is equal to the third item, then it stands to reason to say that the first item was equal to or is equal to the third item as shown in the picture. Substitutive property. So substitution, if A is equals to B, then B can replace any A in any expression. This is used a lot of times. We use that a lot of times in algebra where we can define a number, and if it is in a certain type of equation, then it can always be substituted back into the equation. So there are so many examples with it where you are given a certain equation where you have y is equals to 2x plus 11, and you are told that x is equals to 4. You can simply substitute 4 into the equation to get the value or you are looking for as far as the equation is concerned. So 2 times 4 plus 11. Addition property. The addition property simply will say if A is equals to B, then if you add a third item, C, to both sides, then both items should be equal. Being that if A and B are equal in the first place, then adding C to both sides doesn't really change anything per se. The two items weigh the same, and that is the addition property of equality. Subtraction property of equality. Quite similar to the addition, that if A is equals to B and you subtract C from A and C from B, then nothing has changed. Both items remain the same thing, as suggested by the example below. Multiplication, property of equality. If A is equals to B and you multiply both sides by C, both sides remain the same and therefore it creates the idea of both sides being balanced or both sides being equal. Normally used in algebra, but the same idea will be used widely in geometry as well. So A is equals to B, multiply both sides by C, and you should be able to have both sides being equal. Similar to division property of equality, if you have A and B being equal to each other, and you divide both sides of the equation by C, then it stands to reason that both sides are equal. But we also need to be aware that the equation is divided by the same non-zero number, and therefore the equation should be the same. So, in conclusion, we will discuss a few things that we've talked about. We've talked about reflexive property. We've talked about symmetric property, transitive property, addition, subtraction, multiplication, division, and substitution. And we also will add the zero product property as well. Take note of this, and in our next video, we'll discuss intensively how these are used in geometry and in algebra as well.